Hello everyone, welcome to another YouTube channel. Today we are going to learn about Bohr's atomic model. This model is very useful to study the modern physics. So this model was given by Professor Niels Bohr in 1913. He actually removed the difficulties of Rutherford atomic model, and by applying Planck's quantum theory to it, he proposed a new model which was called by him as Bohr's atomic model. So let us first study the postulates of this model, and then we will use Bohr's theory of hydrogen like atoms to solve the numerical problem. So we will discuss in this video the theory part, and we will discuss the numerical part in the next video. So other postulates, the first postulate was given by Bohr is Bohr's quantization condition. It states that electrons can orbit in only those orbits, or electron can revolve only in those orbits for which its angular momentum, that is mvr, is equal to nh by 2 pi. That means if mvr is integral multiple of h by 2 pi, then only in that orbit electron can revolve. Okay, here m is mass of electron, v is velocity of electron, r is radius of orbit, n is principal quantum number, h is Planck's constant, and n values can range from 1, 2, 3, and so on. The second, and this postulate is also called as Bohr's quantization condition. The second postulate is that while revolving in a stable orbit, the electrons do not radiate energy in spite of their acceleration toward the center of the orbit, and hence the atom remains stable. This postulate actually removed the basic difficulty of Rutherford model, which was unable to explain the stability of the atom. Okay, so while revolving in stable orbit, electron will not lose their energy. Okay, in spite of having Einstein. But in in kinematics or in mechanical physics, you have learned that if something has acceleration, then it will lose energy with the passage of time. But here, the electron will not lose energy with the passage of time, hence it will remain stable. The third postulate of Bohr's model is Bohr's frequency condition, which basically explains that if an electron in lower orbit jumps to an higher orbit, then it must have gained some energy, okay, in doing that. So let us say in higher orbit it has having energy of E2, and in lower orbit it is having energy of uh, E1. Okay, so here you can say, using simple Planck's theory, that is E is equal to h nu, we can take nu and h as same, but instead of E we are taking E2 minus E1. So using this equation, nu is equal to E2 minus E1 on h, we can simply calculate the frequency of the radiated wave when the electron jumps from lower orbit to higher orbit. So these are basically three postulates uh, which we have discussed right now, and using these three postulates we will derive some expression for radius, velocity, and energy for hydrogen and hydrogen like atoms. So let us see those derivations. So first of all, we will assume that for hydrogen like atoms we have atomic number z, so it will contain z into e electrons, sorry, z into e protons, or charge of Ze in the nucleus, and we will consider a single electron revolving this nucleus. So in the diagram you can see easily, here an electron is revolving around the nucleus with a velocity of v. So this electron will keep revolving without radiating an energy. So for this motion to occur, here we have to equate centripetal force of the electron, centripetal force acting on the electron, to its electrostatic force of attraction with the nucleus. Okay, centripetal force is mb square by r, and electrostatic force of attraction, I've told you earlier in the electrostatic video, that 1 by 4 epsilon naught multiplied by Ze into E upon E square R square. So if you simplify this, we will get mb square is equal to Z square upon 4 epsilon naught R. Using first Bohr postulate, we have studied that mbr is equal to nh by 2. So if we square it, this expression, we will get m square v square r square is equal to n square h square upon 4 pi square. Now if we divide equation 2 by equation second, you will get mr square is equal to n square s square upon 4 pi square into 4 pi epsilon naught r upon z square, or you will get finally r is equal to n square h square epsilon naught upon pi m z square. So here h epsilon naught pi m z and e are basically constant, so we can say r is directly proportional to n square. So if orbit number is 1, so 1 square is 1. If orbit number is 2, 2 square is 4. If orbit number is 3, 3 square is 9. So what I'm trying to say is that the ratio of the corresponding radius of the orbit will be equal to 1 is to 4 is to 9. Now let us derive an equation for Bohr's radius. Radius of first orbit of hydrogen atom. So for first orbit n is equal to n, for hydrogen atom z is equal to 1. So we put n is equal to 1 and z is equal to 1 in equation 3 here. So we will basically get r1 is equal to h square epsilon naught upon pi m square. So putting the value of h epsilon naught pi m and e in this expression, you will get r1 is equal to 0.53 angstrom. Okay. Similarly, you can get r2 as 4r1, r3 as 9r1. It is 4 into 0.53 angstrom and 9 into 0.53 angstrom. Keep in mind 1 angstrom is equal to 10 to the power minus 10 meter. Okay. Let us derive an expression for velocity of electron in stationary orbit in the case of hydrogen and hydrogen-like atoms. So again, using Bohr's first postulate, that is mvr is equal to nh by 2 pi, we can write v is equal to nh by 2 pi mr. Now put the expression of r which we have derived earlier in this expression, you will get r is equal v is equal to z square upon 2 h epsilon naught into 1 by n. So here n is equal to 1, 2, 3. So all the constant, if we keep aside, we will get velocity is inversely proportional to principal quantum numbers. That means if an electron is the lowest orbit, it will have the maximum velocity, and in the higher orbit, electron velocity will keep on decreasing. Let us calculate the velocity of electron in first orbit in the case of hydrogen atom. So here and then n will become 1 and at z will also become 1. So keeping the all the values, we will get v1 is equal to e square upon 2h epsilon naught. Put the value of E as 1.6 into 10 to the power minus 19, H is 6.63 into 10 to the power minus 34, epsilon naught as 8.85 into 10 to the power minus 12. We will get V1 is equal to 2.19 into 10 to the power 6 meter per second. And there is a one important thing here I would like to tell you in the note, that if we divide this velocity by c, you will get a number which is known as 1 by 37. So 1 upon 137 is a pure number, and in physics it is known as fine structure constant. We will denote this fine structure constant by the symbol alpha. Now finally, we will derive an expression of energy of electron in a stationary orbit. So whenever electron is revolving an electron, whenever an electron is revolving in an orbit, it carries two kind of energy. One is kinetic energy, one is potential energy. Kinetic energy is simply half mv square. So put the value of v which I have calculated earlier in half mv square, you will get k is as 8 z square upon 8 pi epsilon naught r. And for potential energy which was produced due to electrostatic attraction of the nucleus with the electron, so you will get u as 1 by 4 pi epsilon naught z into e upon r. So you have to keep in mind here we will use the negative sign of the electron, so you will get u as 1 upon 4 pi epsilon naught into z square upon r with minus signs. For total energy, we will add this to energy. So when you will get k plus u, you will write z square upon 8 pi epsilon naught r minus z square upon 4 pi epsilon naught r. In bracket, you will get, if we take z square upon pi epsilon naught r common, you will get 1 by 8 minus 1 by 4, which will become finally minus z square upon 8 pi epsilon naught r. Put the value of r which we have calculated earlier in this expression, you will get finally energy of electron in nth orbit as minus mz square e to the power 4 upon 8 pi epsilon naught 8 epsilon naught square h square into 1 by n square. Again, so one thing you have to keep here in mind, later I will show you that this expression can be simply written as E is equal to minus z square rsc upon n square. So what is r here? R basically is known as Rydberg constant. Its value can be calculated using this expression. m e to the power 4 upon 8 epsilon naught ch cube. Let us come back to this expression first. So here we will try to calculate the photon wave. Here we will try to calculate the wavelength of the photon which is emitted when an electron translated from lower energy state n1 to higher energy state n2. Okay, so whenever an atom gets excited, electron always jump from lower to higher orbit. In doing that, so it will release a photon for which a wave is created. So for that wave we are trying to calculate frequency and wavelength. So for that we need energy difference of those two orbits. So using the above expression we can write E2 minus E1 as m z square e power 4 upon 8 pi epsilon naught square h square up into 1 by n1 square minus 1 by n2 square. Again using Bohr's third postulate we can calculate frequency as E2 minus E1 by h. So nu becomes m z square e to the power 4 upon 8 epsilon naught square h cube in bracket 1 by n1 square minus 1 by n2 square. For corresponding wavelength, we will write 1 by m lambda is equal to nu by c. So 1 by lambda, keep in mind, is known as wave number, and for Rydberg constant, we will use this expression m e to the power 4 upon 8 pi 8 epsilon naught square ch cube. Epsilon naught here is permittivity of free space. Okay, its value is 8.85 in 10 to the power minus 12. Okay, so finally, the Bohr's formula for hydrogen and hydrogen-like atom will become 1 by lambda is equal to z square r in bracket 1 by n1 square minus 1 by n2 square. So we will get we can calculate value of r putting the value of all the constant. M as 9.1 into 10 to the power minus 31, E as 1.6 into 10 to the power minus 19, epsilon naught as 8.85 into 10 to the power minus 12, C as 3 into 10 to the power 8, H as 6.63 into 10 to the power minus 34. So we'll get R as 1.090 into 10 to the power 7. This is empirical value. This value was obtained by Balmer. So energy expression finally, which I told you earlier, that in simple you will get E as minus z square upon RSC, and if in that, so also if we put R as 1.090 into 10 to the power 7, H Planck's constant value, C speed of light, you will get finally E is equal to minus z square upon minus z square into 13.6 upon n square electron volt. 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. And for hydrogen like atom z becomes 1, so this energy expression becomes minus 13.6 upon n square. Okay, so that's all for Bohr's atomic model and Bohr's theory for hydrogen and hydrogen like atom. Thank you for watching this video and have a nice day.